Algebra 1, topic for our second lesson out of our typical text. Okay, the topic is called angles, polygons, triangles, and quadrilaterals. There's actually 4 things here. Don't freak out on it. A lot of information. You'll definitely need to have your notes on it, but that's what we're here for. Let's get into this. Okay. First of all, let's talk about what kind of angles that we can have. And there's actually, when we talk about angles, there is 4 types of angles you can have. You can have acute angles, which means they're less than 90 degrees. An acute angle is an angle that's less than 90 degrees. An example would be an angle that looks like this. See, this part right here is how far those 2 lines, or technically rays, are opening up. That's the angle. This angle right here, oh, that might be around 45 degrees. That's just an estimate if we were to measure it. And notice that 45 degrees is less than 90. So this angle is what we call acute. Now I'm going to jump ahead here. I'm going to go to this one right here. Now, another type of angle we have is what we call a right angle. And right angles are really easy to remember. A right angle is where those 2 lines or rays form a perfect L shape. And usually you designate a right angle with that little box there, meaning, or they are telling you that it is 90 degrees. So notice we have that perfect L. You know, back to elementary, remember when some of you would make those perfect letters? Too bad you can't do that anymore. Well, you know, I can't either. But, you know, that perfect L shape is a right angle. Notice an acute angle, though, is these 2 lines are less than that perfect L shape. Now, another type of angle we have is an obtuse angle. And that's where the angle is greater or bigger than 90 degrees. So you might have those 2 lines that open up more than that perfect L shape. So it's bigger. This angle right here is bigger. This might be around 120 degrees. If we were to measure it with what we call a protractor. That's an obtuse angle. So we have our acute, we have our right angle, and we have our obtuse angle, meaning it's bigger than 90. Now, what's a straight angle? Well, a straight angle is really, it's just a straight line. You know, straight angle, straight line. So in other words, this angle, as we go from here to here, it's 180 degrees. It's a half a turn. What would we have if we made a full turn? Well, that's 360. So a straight angle is actually half of a circle, knowing that a circle is 360. So acute angles, right angles, obtuse, and straight angles. Know them. Now, what we have here is kind of what I call a map diagram of what we call a polygon. Now, a polygon seems like a really weird name, but really it's kind of simple. A poly, the word poly, the prefix poly means many. And so a polygon just means a many-sided figure. Now, let me make a screen here. And so a many-sided figure, I could have something maybe that looks like this, just throw some sides in, something like that, maybe go up. Okay, so I have 1, 2, 3, 4, 5, 6, 7. I have a 7-sided figure. In a little bit here, we'll talk about what we specifically call a 7-sided figure. But you know what? This thing right here I created is a polygon. Now, what do you have to have if you're going to have a polygon? Well, it's got to be a simple figure. Simple meaning it doesn't, get really fancy. So in other words, you don't have something like down here where the sides are crossing, you got lines crossing, a whole bunch of stuff going on. No, it's a simple figure. We have to have straight sides. So in other words, down here, notice in that figure, it's not I don't have a straight side at the top there. I've got a rounded side. Can't have that. It's got to be a closed figure. So notice this one right here, everything doesn't connect. So in other words, a polygon, you got to have, if you're going to make it, it's got to be a simple figure, it's got to have straight sides, and it's got to be closed, and it's called a polygon. You will have that definition a lot. So notice my great piece of art there is a polygon, because it satisfies all those requirements. All right, now polygons. As I mentioned before, there's, for some reason people wanted to name these, and yeah, it is nice to name them because you can refer to what you're talking about a little easier. I'm going to go through this pretty quick. You can pause this and replay it, whatever you want to do. Now, three-sided figure, triangle. Four-sided figure, quadrilateral. Five-sided figure, penta meaning five. Hexagon is 6 sides. Heptagon, which is actually what I have there, is 7 sides. Octagon, which is your stop signs, 8 sides. And all of you that have your school permits, and maybe some of you that have your license here, you do stop at stop signs. And remember, I'm trusting you do that. And a 9-sided figure is what we call a nonagon. And just didn't print that real well, but N-O-N-A. And then a 10-sided figure is a decagon. Now they keep on going, believe it or not. For example, an 11-sided figure is called a 11gon. And a 12-sided figure would be a 12gon. And they just make it real easy. That way they just throw in the number of sides and then G-O-N. Concave versus convex. I'm going to put that versus in between those. Know the difference between these. Now, first of all, are those two figures polygons? Let's see, are they simple? Do I have any sides that cross? No, I don't have any sides that cross, so they're simple. Are they closed? Yeah. Do I have all straight sides? Yes, I do. So I have polygons here, don't I? Now, this one would be, let's see, 1, 2, 3, 4, 5. What do we call that? Pentagon. Good answer. How about this one on the right? 1, 2, 3, 4, 5, 6. Hexagon is what we have there. All right, so I'm going to erase that, and I was hoping that the red one erased, and it didn't, so that's a good thing. All right, concave simply means this. Concave just simply means, can I place 2 dots any place in the figure? And actually, I'm going to back up a step. I'm going to make this a little simpler. Let's go to convex first. A little easier to start with that one. Convex means you can put 2 dots any place and connect them, and the whole line will be inside the figure. Is that whole line inside the figure? Yes, it is. How about if I put 2 dots over there, connect them? Is that whole line inside? You bet. How about here? And you know what? No matter where I put 2 dots and connect them, the line's going to be in the figure. That's convex. But concave means you cannot put 2 dots and connect them so the line lies entirely in the figure. Notice there, I cannot. Sure, I could over here. But you know what? If it's going to be convex, you got to be able to put 2 dots any place. Notice here, I put them there. Automatically, that makes it concave. Some of you may want to remember it as, oh, it caves in. Well, concave. That's a good way to remember.